section 2.1. We get inductive and deductive reasoning. Our essential question: how can you use reasoning to solve problems? 3 definitions to start us off. Our first is conjecture. Conjecture is an unproven statement based on observation. Then we have inductive reasoning. Inductive reasoning is the process of finding a pattern and making conjectures based on it. And then a counterexample is a specific case which shows that a conjecture is wrong. So, example of this, we go to a lake, I throw in a board, it floats. I throw in styrofoam, it floats. I throw in ice, it floats. My conjecture, okay, my unproven statement based on observation, is solid things float. So I'm using inductive reasoning of seeing a pattern to make the conjecture that solid things float. Not all solid things float. So a counterexample of that would be a brick. Because you throw a brick in the water, it's going to sink. That's a specific case where it doesn't work. So that is what I want for a counterexample. The specific case where the counterexample is not working. Or where the conjecture is not working. So we're going to look at some examples, starting with our patterns. So example 1 says, describe how to sketch the fourth figure in the pattern, then sketch the fourth figure. So if I notice here, right, we have a rectangle. I throw a bar across it, and this is shaded. Right? When I come to the next one, they now put a bar down, cut into 4 sections, and the left-hand corner is now shaded. Figure 3, I now have 2 bars coming down, split into even sections, just like the other 2, and the left-hand corner is shaded. So I want a picture that is a rectangle, same size as the ones drawn there. I want a line coming across the middle. And instead of 2 lines and having 3 blocks here, we're going to have 4 blocks. So we went from 1 to 2 to 3 on the bottom. And we do our best to set it. These are all even, so I'm doing my best to set those up as even, and my left-hand corner is shaded. Example 2 says sketch the 5th figure for example 1. So that would have, instead of 4 going across, it would have 5. So again, I'm trying to set up my rectangle exactly the same size. Try to evenly divide that to 5 sections, and the left-hand corner is still shaded. Okay, so I'm following the pattern. Example 3 says describe the pattern in the numbers -1, -4, -16, -64, and write the next 3 numbers. When I'm describing the pattern, there's a couple things you can use here. Right? I can look at how my numbers are changing. Sometimes that's adding, sometimes that's subtracting, sometimes that's something else you can see. In this case, each one of these previous ones is getting multiplied by 4. So my pattern would just be times 4. So then -64 times 4 is -256. -256 times 4 is -1024. And -1024 times 4 is -4096. And those are my next 3 numbers. Realize we're doing this as a pattern. If the negatives were shifting, right, you could say this is by -4. You could also say it's times 4 and the negatives switch on and off. It switches from negative to positive. Also realize we don't know where they got these numbers from. So this is the pattern. Would be my correct answer. But I always give the example of if I'm rolling a die. If I get 1, 2, 3, 4, everybody looking at that pattern would say the next thing is 5. But if I'm rolling a dice, I don't know what it's actually going to be. It's going to be somewhere between 1 and 6. And when you get to the third one in the pattern and you say 7, that's definitely going to be wrong. So this is judging it by the pattern, okay, not necessarily by what's behind the pattern. Example 4 says describe the pattern in the numbers. Write the next number in the pattern. So I have -5, -2, 4, 13. Okay. So when we're looking at those, we're looking at how do I get from one to the other. Okay. So we just use multiplication. If I look at multiplication, I don't see anything. So next thing to look at is how would I just get to the numbers. So here, what I would probably do is say I would do +3 there, right, to get from -5 to -2. To get from -2 to +4, I'm adding 6. To get from 4 to 13, I add 9. So what I'm doing is I'm adding an increasing multiple of 3. And you could write that out as like an algebra type problem. Okay, you can show what's going on here. But the key thing if you're being asked for describe the pattern is that you know what's coming next. So what you're showing says what's coming next. So what's going to be next is +12, which gets me the next number of 25. So then example 5 says in the following exercise, show the conjecture is false by finding a counterexample. So A says the sum of two numbers is always greater than the larger number. Okay, so I want to add two things here. Okay, because it says the sum. So to show it's greater, I have to be adding. But when I add these, I want the number to be smaller than the larger number. So I'm going to put a 7 here and say, what can I add to 7 that's going to make it the answer here smaller? Well, what I can add to it is a negative number. If I add -1, -1 plus 7 gets me 6. 6 is smaller than 7. So then it's not a larger number, and that shows it's false. And any positive number and any negative number is going to work there. B says if the product of two numbers is even, then the two numbers must both be even. So first I need to think about what product is. Product means I'm multiplying, right? So I'm multiplying two things. It says the product of the two numbers is even. So what I want is this number has to be even, but I want both of these numbers to not be even, because this says that two numbers must be even. Realize, I always have people who have issues with this. This says find a counterexample. That means there is a counterexample. There's a lot of them here as well. I'm going to say 4 times 5. 4 is even, 5 is not. My answer is 20. That is even. That is a counterexample. Then C, the product of A plus B squared is equal to A squared plus B squared for A and B not equal to 0. Okay, so I want to be able to plug numbers in there and have them A and B not equal to 0 and have this not be equal to that. Okay. So I'm going to go with 3 and 4. Okay, if I have 3 plus 4 squared, that's 7 squared, which is 49. If I do 3 squared plus 4 squared, right? So we said this is 7 squared, which is 49. That is not equal to this, okay, which is 9 plus 25, which is equal to 36. Okay, so those two things are not 36. Well, 34. I did something weird there. 3 squared. Oh, this is 16. That's why my answer is wrong. Weird. 4 squared is 16. Make sure you do your math right. 4 squared is 16. So then my answer is 25. I knew there was a 25 there. So then we have two things here. We have deductive reasoning, and then we have two laws with the deductive reasoning. So deductive reasoning is using known facts to support a logical argument. Deductive reasoning is what you normally do in a math class. If I give you an algebra problem, if you follow the rules, you get the right answer. That is deductive reasoning. I'm not looking at a pattern. I'm not making a guess. We're following the rules, so we know it's going to work. So our first law with that is the law of detachment. It says if the hypothesis is true, then the conclusion is true. Okay, so example 6 says if two angles are right angles, then they are congruent. C and D are right angles. So if this is true, then what do I know if C and D are right angles? Well, I know they have to be congruent. So angle C is congruent to angle D. That is the law of detachment. Okay. So example 7, and this is where we normally get into some issues. Mary goes to the movies every Friday and Saturday night. Today is Friday. So my conclusion is Mary goes to the movies. Right? It tells me she goes every Friday and Saturday night. It's Friday. She's going to the movies. Okay. When you're using the law of detachment, don't bring other things into it. Don't say, well, what if the movie theater blew up? Right? What if Mary's sick? What if an asteroid hit Earth and no one's alive anymore? It doesn't matter. It's Friday. Mary's going to the theater. Okay? The theater could be completely obliterated and gone. Mary's still going. All right, so don't bring other things into it. That's always the problem with these statements, is people look at this and this, and they say, well, what if this happens? Don't bring that stuff into it. Just look at what this is saying and make your conclusion. Then we have the law of syllogism. Okay? The law of syllogism, I think, is really easy, but this is really confusing. So I'll go through this, and then we'll look at the example, and I'll say why I think it's easy. All right? So it says, if hypothesis P, then conclusion Q. If hypothesis Q, then conclusion R. And if hypothesis P, then conclusion R. All right? So this is just a way of writing if-then statements where they're not specific. So what you're saying is, if these two statements are true, then this has to be the case. That's our law of syllogism. Okay? And it's weird in the way it's written there, all right, at least for beginners. But if we look at example 2, it says, if Joe takes geometry this year, then he'll take algebra 2 next year. If Joe takes algebra 2 next year, then he will graduate. So the stuff about him taking algebra 2, right, this stuff, it's in both statements. Yeah, then he'll take algebra 2 if he takes algebra 2. So we don't really need that. So the law of syllogism is saying I can get rid of that. I can get rid of the if and then that say the exact same thing and write one statement. So if Joe takes geometry this year, then he will graduate. So we look at B. If you do homework, then you can watch TV. If you watch TV, then you can watch your favorite show. So the watching TV here is the repetitive part. Right? Both things say, then I watch TV, if I watch TV. So if I do my homework, then I can watch my favorite show and change the words up. So if you do your homework, then you can watch your favorite show. And then the third one, or last one here, is a math one. If y squared equals 8, then y equals 2. If y equals 2, then 3y plus 4 equals 10. So again, the y equals 2, that's what I could solve these and find that, but it's not really helpful to what it's saying. So if y squared equals 8, then 3y plus 4 equals 10. And that is my conditional statement. Okay, and that is the end of our section 2.2 on, I forgot what that was on. Oh, inductive and deductive reasoning.